ठीक है।
Power quality analysis is the process of monitoring and analyzing an electrical power supply to identify and address issues that can negatively impact equipment, performance, efficiency, and safety. It involves measuring and analyzing various parameters like voltage, current, frequency, harmonics, and transients. Need of power quality analysis. Power plants, whether thermal, hydro, nuclear, renewable, and industries, require stable power quality for seamless operations. Voltage and frequency fluctuations. Voltage sags, surges, harmonics, and transients, which can directly affect turbines, generators, and transformers, leading to performance degradation, unexpected shutdowns, and higher maintenance costs. Harmonic distortions are another critical issue, causing excessive heating in critical equipment, can lead to equipment failure, reducing efficiency, and increasing power losses. We, Oorja Technical Services Pvt. An ISO IEC 17025 NABL accredited laboratory performs on-site power quality analysis. Let's explore the user-friendly navigation menu. U. Voltage. Voltage measurements are critical to understanding power quality, as deviations from nominal voltage can indicate power quality issues. I. Current. Monitoring current helps to identify potential overloads or abnormal electrical behavior. Frequency. Frequency deviations from the standard 50 Hz or 60 Hz can indicate instability or irregularities in the power supply. Power. In power screens, instrument shows measured power parameters. Energy. Instrument shows status of energy counters in a tabular meter form. Harmonics. Harmonics presents voltage and current signals as a sum of sinusoids of power frequency and its integer multiples. If a signal decomposition with Fourier transformation results with presence of a frequency that is not integer multiple of fundamental, this frequency is called interharmonic frequency, and component with such frequency is called interharmonic. We provide harmonics measurement up to 50th order in HT and LT panel. Flickers. Flickers measure the human perception of the effect of amplitude modulation on the mains voltage, powering a light bulb. Phase diagram. Phase diagram graphically represent fundamental voltages, currents, phase angles, and unbalance of the measured system. This view is for checking instrument connection before measurement, because most measurement issues arise from wrongly connected instrument. Temperature. Our instruments are capable of measuring and recording temperature with temperature probe. Over deviation. Basic measurement for the under deviation and over deviation is RMS voltage magnitude measured over a 10-12 cycle time interval. Key benefits. Audit-ready technical report for system improvement plan. Automatic line harmonics measurement up to 50th order with 7 days continuous flicker recording facility as per IEEE 519 and IEC 61000 is recommended for renewable energy power plant compliance requirements. Automatic voltage, current, power factor, inactive. Reactive power measurement facility, improved energy efficiency, enhanced equipment reliability, performance, and lifespan. We would be delighted to discuss how our electrical testing services can support your business needs. Power quality analysis is the process of monitoring and analyzing an electrical power supply to identify and address issues that can negatively impact equipment, performance, efficiency, and safety. It involves measuring and analyzing various parameters like voltage, current, frequency, harmonics, and transients. Need of power quality analysis. Power plants, whether thermal, hydro, nuclear, renewable, and industries, require stable power quality for seamless operations. Voltage and frequency fluctuations. Voltage sags, surges, harmonics, and transients, which can directly affect turbines, generators, and transformers, leading to performance degradation, unexpected shutdowns, and higher maintenance costs. Harmonic distortions are another critical issue, causing excessive heating in critical equipment, can lead to equipment failure, reducing efficiency, and increasing power losses. We, Oorja Technical Services Pvt. An ISO IEC 17025 NABL accredited laboratory performs on-site power quality analysis. Let's explore the user-friendly navigation menu. U. Voltage. Voltage measurements are critical to understanding power quality, as deviations from nominal voltage can indicate power quality issues. I. Current. Monitoring current helps to identify potential overloads or abnormal electrical behavior. Frequency. Frequency deviations from the standard 50 Hz or 60 Hz can indicate instability or irregularities in the power supply. Power. In power screens, instrument shows measured power parameters. Energy. Instrument shows status of energy counters in a tabular meter form. Harmonics. Harmonics presents voltage and current signals as a sum of sinusoids of power frequency and its integer multiples. If a signal decomposition with Fourier transformation results with presence of a frequency that is not integer multiple of fundamental, this frequency is called interharmonic frequency, and component with such frequency is called interharmonic. We provide harmonics measurement up to 50th order in HT and LT panel. Flickers. Flickers measure the human perception of the effect of amplitude modulation on the mains voltage, powering a light bulb. Phase diagram. Phase diagram graphically represent fundamental voltages, currents, phase angles, and unbalance of the measured system. This view is for checking instrument connection before measurement, because most measurement issues arise from wrongly connected instrument. Temperature. Our instruments are capable of measuring and recording temperature with temperature probe. Over deviation. Basic measurement for the under deviation and over deviation is RMS voltage magnitude measured over a 10-12 cycle time interval. Key benefits. Audit-ready technical report for system improvement plan. Automatic line harmonics measurement up to 50th order with 7 days continuous flicker recording facility as per IEEE 519 and IEC 61000 is recommended for renewable energy power plant compliance requirements. Automatic voltage, current, power factor, inactive. Reactive power measurement facility, improved energy efficiency, enhanced equipment reliability, performance, and lifespan. We would be delighted to discuss how our electrical testing services can support your business needs.
Good afternoon, everyone, and welcome. Thank you for joining us today. Whether you are turning in from your home, office, workplace, or somewhere in between, we are thrilled to have you with us for this session. My name is Roshni Nishad, and I am moderator for today's webinar titled Precious Power Quality Measurement and Diagnostics. The session will last about 1 hour, and we all have a live question and answer at the end. So I encourage you to drop your questions into the chat at the end. We all get to as many as we can. This webinar is designed to be interactive and practical. So feel free to take notes, participate in polls. Let's get started. And again, thank you for investing your time with us today. I request our technical expert Kuldeep sir to take over from here.
Good evening, everyone. Myself is Kuldeep Gautam, and I have more than 15-year experience in the electrical testing and calibration field. And in today's session, we explain into the critical topic power quality measurement and diagnostic using precision analyzer with increasing complexities in the modern power system. Accurate power quality monitoring is no longer optional; it essential. In this webinar, we will explain the importance of power quality measurement, losses of poor power quality, parameter list of power quality measurement, about power quality instrument details, guidelines, and diagnostic or improvement points. This webinar is designed to empower professionals from the electrical, pharma, electricity generation plants, industrial research domains with advanced knowledge and techniques and practice insight into identifying, analyzing, and resolving power quality issues. Let's bring this power packed session and take a step closer to excellence in energy diagnostics. Before start the webinar, I want to introduction on company profile, electrical profile. Oorja Technical Services is an ISO IEC 17025, ISO 9000 2015 certified enable accredited laboratory in the field of mechanical, electrotechnical, thermal, calibration, and electrical testing services. Oorja Technical Services is provide the one-stop solution in the electrical testing and calibration field. In electrical division, we are provided the multiple service which are shown in below chart. In we are providing the electrical services multiple sectors in transformer testing and maintenance, electrical testing and calibration maintenance, switchgear testing and maintenance. In transformer testing, we are providing the transformer oil filtration services, transformer oil testing services, transformer testing, maintenance, oil leakage arresting work. In electrical testing, we are providing the earthquake testing, circuit breakers, thermography of electrical components, insulation resistance tests, UPS battery testing, calibration of energy meters, digital multimeter, ampere meter, volt meter, high voltage breakdown tester, WTI, OTA testing and calibration of current transformer, testing and calibration of potential transformer, reference meter, electrical instruments, and power quality testing. In switchgear testing and maintenance, we are providing the circuit breaker testing, ACB, VCB overhauling services, vacuum circuit breaker overhauling, high port testing, and relay testing. Now come back to webinar agenda topics. Why the power quality measurement required and importance. Second is the what parameter check in the power quality measurements. Third is power quality instrument details and guidelines like instrument details, connection, automatic report generation. Fourth is what are the losses of poor power quality used for electrical system. Fifth, diagnostic and improvement details. First point, why the power quality measurements are required and importance. Power quality analysis is the process of monitoring and analyzing an electrical power supply to identify and address issues that can negatively impact equipment performance, efficiency, and safety. It involves measuring and analyzing various parameters like voltage, current, frequency, harmonics, and transients. We can identify that the received power is good quality and compliance with the standard and regulations. In next slide, we are trying to explain the more. We are trying to explain the some important points which are expressed that why power quality measurement is important. First, preventing equipment malfunction and downtime. Power quality issues like voltage shakes, slaves, and harmonic can cause sensitive equipment to malfunction, leading to unexpected shutdowns, data loss, and costly repairs. Second point is improving efficiency and reducing energy costs. High power quality ensure equipment operates at optimal efficiency, reducing energy consumption and lowering electricity bills. Third point, ensuring compliance with standards and regulations. Many industries and utilities have specific power quality standards and regulations that must be met. And power quality measurement help ensure that electrical systems are in compliance, avoiding penalties and legal issues. Fourth point is protecting sensitive equipments and data. Thermal, hydro, nuclear, renewable energy power plants, research establishment, data center, hospitals, and other facilities with critical equipments maintaining a stable and reliable power supply essential. Power quality measurement help ensure that sensitive equipment without interference and that valuable data is protected from corruption or loss. Fifth point, optimizing system performance and reliability. By identifying and address power quality issues, business can optimize the performance and reliability of their electrical system. This includes ensuring proper functioning of motor, transformers, and other critical components, leading to improved overall system performance. Harmonics current increase the losses in the transformers and conductors. Power quality measurement are protective approach to managing electrical system, ensuring efficiency, reliability, and safety while minimizing cost and risks. In next slide, what parameter check in the power quality measurement? Measurement of power quality problems. Power quality measurement instruments can measure the multiple electrical parameter, but here we will explain the problems which are affect on power quality. Power quality problems can be broadly classified into the following categories: voltage, magnitude variation, shakes, slaves, interruption, current magnitude unbalance, frequency, power factor, harmonic distortion, including TSD, flickers and transients, spikes and impulses. These measurements help identify and address issues like voltage dip, harmonic distortion, and grounding problems, which can affect equipment performance and efficiencies. Voltage 6. A decrease of normal voltage level between 10% and 90% of normal RMS voltage at the power frequency for duration of zero point 0.5 cycle to 1 minutes. Reasons: fault on the transmission and distribution network, fault in the consumer installations, connection of heavy loads, and startup of large motors. Results: a malfunction of processor based control system may lead to process stoppage, disconnection, and loss of efficiency in electrical rotating machine. Next, voltage spikes. The total interruption of electrical supply for duration greater than 1 second to 2 seconds. Region: lighting, switching of lines, or power factor correction factors. Disconnection of heavy loads. Results: destruction of component and of insulation materials. Data processing errors or data loss. Electromagnetic interference. Voltage swells. Momentary increase of the voltage at the power frequency outside the normal tolerance with duration of more than 1 cycle and typical less than a few seconds. Reasons: start stop of heavy loads, poorly dimensioned power sources, poor regulated transformers. Result: flicking of lighting and screens. Damage or stoppage or damage of sensitive equipments. Frequency. Normal frequency, typically all instruments operate at 50 or 60 Hz depending on region. Frequency deviation. Variation from the normal frequency which can affect the operation of some equipment. Frequency deviation from the standard 50 Hz or 60 Hz can indicate instability or irregularities in the power supply. Power factor. A measure of how frequently electrical power is being used. A low power factor can indicate wastage of energy and may require corrective measures. Flickers, a measure of voltage fluctuation that can cause visual disturbance, flickering lights, and affect sensitive equipment. Flickers measure the human perception of the effect of amplitude modulation on the main voltage powering a light bulb. Here, two types of flicker can measure. First is short-term flicker, second is long-term flicker. Harmonic distortion. Current or voltage waveforms assume non-sinusoidal shape. The waveform corresponds to the sum of the different sine waves with different magnitude and phase, having frequencies that are multiples of power system frequency. Total harmonic distortion, a measure of overall harmonic distortion in a signal. Region, classic source and modern sources. First, classic source. Electrical machine working above the knee of the magnetizing curve. Saturation, arc furnace, welding machine, rectifiers, and DC motors. Modern sources, all non-linear loads such as power electronics equipment, including ASD, adjustable speed drives, switched mode power supplies, data processing equipment, high efficiency lighting. Harmonic present voltage current signals as a sum of sinusoid of power frequency and its integer multiples. Results of harmonic distortion. Increased probability of occurrence of resonance, nuisance stripping of thermal protections, electromagnetic interference, increase in the loss of efficiency in electrical machine, for example with harmonics. The above parameters are not limited to measure. We can measure the other parameter also like active power, reactive power, power factor, frequency, energy, etc. based on customer requirements. Then next agenda point is the details of power quality instruments and guidelines like instrument details, connection, automatic report generation. In the market, different class power quality measuring instruments used by vendor and parties, but which is the best for power quality measurement? For reliable and accurate or precise power quality analysis, Class A power quality analyzer is generally considered the best option. Class A instruments adhere to the strict performance and accuracy standard outlined in the IEC 61000-4-30 standards, ensuring reliability and comparable results. So we need to confirm the instrument class from vendor which will use to power quality measurement in the plant. This instrument is compliance with the standards and state electricity regulations like solar plants, power plants, other electrical system. Compliance requirement IEEE 519. Adhering to industry's standards like IEEE 519 is essential for safe, reliable, and efficient electrical system. This standard set the limits on harmonic distortion levels. IEEE 519 2014 provide guidance for harmonic control in electrical power system, stabilizing limits for current and voltage harmonics at the point of common coupling. Precision analyzers are key to verify compliance and avoiding potential penalties or equipment damage for excessive harmonics. We perform with metal make class A power quality analyzer which having a continuous 7 days data recording facility as per standard IEEE 519. IEEE recommended practice and requirements for harmonics control in electrical power system. An automatic Report generation software to avoid the calculation mistake as per IEEE 519 and EN 50160. In this slide, we are showing two table for harmonic limits with harmonic limits. One is the voltage distortion limits, and second is table is showing the current distortion limit at different voltage level. As per IEEE 519, we need to measure the del 99 percentile very short time and 99 percentile short time, 10 minutes in the voltage harmonics and current harmonics. In next slide, we are showing automatic report generation. It is generated by this instrument. In this slide, we are showing the IEEE 519 reports and energy demand reports. And energy demand reports cover the active, reactive, power, energy, power factor, unbalanced load condition, and harmonic control electrical power system also. Connection of instrument. Generally, power quality instrument is connected at secondary side of CTPT to measure the precise measurement. If special requirement of customer, then engineer is connect the instrument with the system after understand the requirement or condition to measure the harmonics. In this slide, we are showing some connection diagram, 3-phase 3-wire, 3-phase 4-wire, single phase 2-wire, and left side we are showing the how to connect the instrument with system at fields in field. In this slide, we are showing the instrument image and measurement parameter option: voltage, current, frequency, power, energy, harmonic, flickers, phasor diagram, temperature, signaling, under voltage or deviation. Next agenda point: what are the losses of poor quality used? What are the losses of poor power quality used for electrical system? One of the primary results of poor power quality is the potential for damage to sensitive electronic components and device. Voltage malfunctions, harmonics, and transit can cause overheating, insulation breakdown, and even complete failure of electrical equipment, resulting in costly repairs and replacement. Voltage and frequency fluctuation, voltage shakes, surges, harmonics, transients, which can directly affect turbines, generators, and transformers, leading to performance degradation, unexpected shutdown, higher maintenance costs. Harmonic distortion are other critical issues, causing exclusive heating in critical equipment can lead to equipment failure, reducing efficiency, increasing power losses. Next agenda, diagnostic and improvement details. To improve poor power quality in a electrical system, focus on identifying the root cause through power quality analysis, then implementing solutions like harmonic filter, surge protection, voltage regulation, and power factor corrections. Regular power monitoring and using high quality electrical equipment are contribute to better power quality. Harmonic filters. Harmonic filters are used to reduce the undesirable harmonics. They can be divided into two groups. One is a passive filter, then second is the active filters. Consists in a low impedance part to the frequencies of the harmonic to be attenuated using passive components, inductor, capacitor, resistor. Active filters analyze the current consumed by the load and create a current that cancels the harmonic current generated by the load. Surge protection devices protect equipment from voltage surges and transients which can damage sensitive electronics. Voltage regulators stable voltage fluctuation and maintain a consistent voltage level. UPS UPS provide the power during outage and protection against voltage dip and shakes. Power factor improvement. To improve the power factor, use the capacitor bank. Other improvements. Use high quality electrical equipment which are designed to withstand high voltage variation. Ensure the proper grounding to minimize the noise and interference in the system. Employee technologies like variable frequency drive and LED lighting, which can also improve power quality. Final conclusions. The availability of electrical power with high quality is crucial for the running of the modern society. If some sectors are satisfied with the quality of power provided by utilities, some other are more demanding. To avoid the massive losses related to power quality problems, the most demanding consumers must take action to prevent the problems. Among the various measures, section of less sensitive equipment can play as important role. When even the most robust equipment is affected, then other measures must be taken, such as installation of restoring technologies, disturbance generation, or interference device to avoid power quality problems. For the introduction and implementation of power quality and other electrical testing services, we are at your disposal at any time. Thank you so much.